Welcome to all attendees. My name is Valentin Rudloff. I'm part of the UN Climate Technology Center Network and will be hosting today's webinar. Just one administrative note before we start. This webinar is recorded and will be published on the CTCN website. However, no information on yourself as an attendee will be disclosed with this recording. This webinar number 1 on Blockchain 101 and governance is part of a larger webinar series of 6 webinars on the topic of blockchain technology for climate policy implementation. The webinar series will run until the end of January next year and will touch on topics such as energy markets, mitigation and adaptation finance, carbon markets, and value chains. And the webinars are delivered by the UN Climate Technology Center and Network in collaboration with our network member, the Blockchain and Climate Institute. The CTCN, as you can see, is the implementation arm of the UNFCCC technology mechanism. The center promotes the accelerated transfer of environmentally sound technologies for low carbon and climate resilient development at the request of developing countries. The CTCN provides technology solutions, capacity building, such as this activity here right now, and advice on policy, legal, and regulatory frameworks tailored to the needs of individual countries by harnessing the expertise of a global network of technology companies and institutions. And our network member, the Blockchain Climate Institute, is a volunteer-led not-for-profit organization that was founded at COP23 in 2017, and it's combining the functions of a think and do tank and an advocacy group supporting governments and businesses in the deployment of blockchain and emerging technologies in the climate change policy implementation. The mission of the BCI is to affect positive change by raising awareness among the international climate change policy community of the tremendous potential of blockchain technologies to considerably enhance and accelerate climate actions. So today's webinar will cover the core concept of blockchain, as it is the first webinar of our series. It will also cover its types and benefits, cryptocurrencies, smart contracts, and blockchain governance. Key questions are: what is blockchain technology and how does it differ from other types of data networks? What makes it secure and transparent? How can a blockchain be governed? And yes, these topics will be covered by Mr. Alistair Mark, Director General of the BCI, with a guest contribution from Dr. Adrian McCullough, Digital Commerce Committee member of the Law Council of Australia on blockchain governance. We will have about 20 to 25 minutes of introduction to the topic, followed by 20 to 25 minutes intervention on governance, and we'll close with a 10 minutes Q&A session. Please do not hesitate to already send your questions through the Q&A function during the webinar so that we can collect the questions. You can just click at the button on the very right on the 3 dots, and there you can see the Q&A function. I also want to take this opportunity to quickly introduce our 2 speakers of today, starting with Mr. Alistair Marke, who is the Director General of the Blockchain Climate Institute. He's a co-drafter of the ISO 14097 Climate Finance Standard and a UK representative on ISO 22739 Blockchain and Distributed Ledger Technologies Standard Working Groups. And our guest speaker today, Dr. Adrian McCullough, is a member of the Australian Law Council Digital Commerce Committee, member of the Queensland Law Society Digital Privacy Committee, and the Queensland Law Society IT Law Committee. And at BCI, he's involved as the special advisor to the Director General. He holds a PhD in IT security and has more than 30 years of experience in IT security law practice. So this is enough for me, enough for now from my side. It is my pleasure now to hand over to Mr. Alistair Mark to provide an introduction to Blockchain 101.
Cool. Can I share screen now?
Now you can share your screen. Please go ahead.
Can you see my screen now?
Yes, perfect.
Okay, good. Okay. Okay, good morning, good afternoon, and good evening, ladies and gentlemen around the world. My name is Alistair Mark. I'm the Director General of the Blockchain and Climate Institute. I'm quite glad that after our initial online course for all the government officials of the national designated entities of the CTCN, we now open this webinars to all of you. It's for a broader exchanges with all of you regarding these emerging issues on DLT, blockchain technologies, and climate change policy implementation. So today, I would like to start with introducing our optional guidebook. If you want to have or even own one at some point. This is the world's first book combining blockchain and climate change policy issues, published already in 2018, and is now available in nearly 150 university libraries worldwide. And I'm sure you can get hold of a copy quite easily on major online bookstores. We have already finished our in-house research projects on governing carbon market with distributed ledger technologies, and over 55 governments have attended our blockchain information session for carbon market negotiators before COP26 started, and we're going to publish this book with the Cambridge University Press this time, called Governing Carbon Markets with Distributed Ledger Technologies, which is a legal, a law reference book for a legislator, policymaker, anyone interested in carbon market governance in the new Paris Agreement era. And then this book will probably be available sometime in spring next year. It's now in production in the by the Cambridge University Press. So without duplicating what Mr. Rudloff said, introducing the BCI earlier on, I'll just focus on our work programs. So we in BCI, we now have an international network of over 150 colleagues serving in 11 divisions worldwide, and we have at least one pilot program per continent now. And basically, our work programs are divided into eight work streams, ranging from renewable energy, emissions management, biodiversity conservation, smart cities, ocean governance, adaptation, resilience to circular economy, and sustainable finance. And a lot of work has been or are being done in-house or with our partner governments. So stay tuned for all our work programs, which we can publicize in due course. So for this webinar, I'm going to give you a blockchain 101 and introduce the governance model on the blockchain. So first of all, I'd like to share with you a video introducing blockchain very briefly in 1 minute.
Blockchain is a specific type of database that can be used to track and record anything of value from physical financial transactions to carbon credits. At the core of the blockchain are several key features which help us address challenges that were difficult to overcome with traditional databases, without the need to rely on one central authority. The first concept is distributed ledger technology, that data stored over a network of hundreds, sometimes thousands of computers. These computers keep in sync to update and guard the database using consensus mechanisms, that is, coded algorithms that determine which transactions are legitimate according to the majority, clean copies, and establish the rules by which data is recorded. Another key feature of blockchain is its immutability, where whatever is recorded onto a block is fixed permanently there and can never be changed or deleted. These features together make blockchain tamper-proof against hackers' cyber attacks. Blockchain is best put to use to record the transfer of anything of value because it offers built-in token architectures that allow you to issue your own tokens or coins, which are digital representations of assets, or we call them asset-backed tokens, that can be traded securely on the blockchain. In addition, smart contracts can also be programmed on the blockchain to automate and self-execute transactions, providing autonomy, accuracy, and efficiency. There are different types of blockchain. Our choice of types of blockchain should depend on our specific needs. Some are public and open to anyone to view and access, others are closed to a selected group of users. This type of trusted peer-to-peer interaction with real-time data can revolutionize the way large stakeholder groups can access, verify, and transact with one another, resulting in much lower transaction costs yet providing transparency. As the blockchain network does the trust building for us, we now have the opportunity to monitor, report, and verify the transactional data in real time without intermediaries. These features working together can bring transformational changes to global climate markets and governance.
Okay, yeah. So this video is quite good to summarize what I have to say in the next 20 minutes. And the key benefits of using blockchain or wider distributed ledger technologies include transparency, accountability, efficiency, and stakeholder integration. By transparency, it means that all parties can use an app to monitor the necessary processes, and donors can view donation history and the projects they help fund. Charities and implementing partners can check fund disbursement details for work carried out. In terms of accountability, if we have the transparent records that facilitates the transactions, an implementing partner can be held accountable for holding up a project because records clearly show incomplete work, for example, in the adaptation infrastructure construction project. Automatically transferring payment to relevant parties on implementation of work without a central authority can increase efficiency in the transaction process that would otherwise be more time consuming and incur high transaction cost. All parties are able to play their roles on the value chain with the help of this technology. So the use of DLT could probably ensure that there's a better stakeholder integration in all the project processes. So what is blockchain? In short term, blockchain means a distributed ledger. So what are distributed ledgers? Distributed ledger is a database that is shared across a network of computers, which keep in sync when updates occur, like a decentralized database. So as you can see from the diagram on this slide, on your left-hand side, it is a traditional centralized ledger, where all the banks, for example, have to go through a central clearinghouse when they deal with the transactions. This is the current transaction model in our world at the moment. But in a distributed ledger in the future, if we use distributed ledger on the blockchain, all these units no longer need to go through a central middleman called a clearinghouse, so they transact with the other parties directly on a peer-to-peer basis. So I'll explain technically how it will happen in a moment. So a blockchain is a specific type of distributed ledger that arranges information in blocks. So as we have worked on building up new policy knowledge or new legal knowledge on the use of these emerging digital technologies, our researchers have reorganized a blockchain into 6 key concepts, including distributed ledger, cryptography, immutability, consensus mechanism, smart contract, and asset-backed tokens. So in the interest of time, I'm not going to go in depth into all these 6 core concepts. Instead, I will focus on consensus mechanism, smart contract, and asset-backed tokens, which are quite significant in terms of supporting digital infrastructure for all the climate change related applications, which we will share in upcoming webinars. After I go through very briefly all the first 3 concepts. Okay, the First core concept, decentralized or distributed ledger. So as I said before, the blockchain is distributed ledger where users can transact directly with the users without any intermediaries. So this is what we call a peer-to-peer networks in a distributed transaction model. In terms of the second core concept, cryptography, how can we guarantee security if we do not have an intermediary? It's all about the three main processes in cryptography, including cryptographic hashing, Merkle trees, asymmetric keyed cryptography. So on a blockchain, each unit of transaction or data is equipped with a very unique hash, hash, which is like a unique identifier to guarantee that this is the only named in which we'll call those blocks or data file out from the system. And then hashing is in simple terms means to take an input string of any length and give out an output string of a fixed length. In the context of cryptocurrency like Bitcoin, the transactions are taken as an input and run through a hashing algorithms, which gives an output of a fixed length. For example, if we use a hashing calculator to hash two English word hi and welcome, so you see that there is a output string of a fixed length next to hi and welcome in the table I have on this slide here. This is what I meant by hashing. This is a language understandable to the computer system, but not to the human being. So if we put hash into use, say in a carbon offset project management, and I input all those carbon offset project dummy data on a hash calculator. So including area, buyer, carbon credits, project cost, validity period. When I click calculate, it generates a unique hash that identified this file or transaction. However, if I input something extra like second buyer, I'm trying to do Jupiter Chemicals Limited, yeah. Then when I click calculate again, the hash becomes very different. So the point I'm trying to convey to you here is that the use of cryptographic hashing is at the forefront of guaranteeing the security of all the blockchain data on the network. The third concept is immutability. All stakeholders should be happy because they see a permanent record which shows the history of all their data. So in a computer file, we have CRUD functions: create, read, update, and delete. However, on a distributed ledger network or blockchain network, we can only allow read and write. Yeah, which form a permanent record. It means, to put it simply, once you enter some information onto the blockchain, you cannot change it forever. That's the theory here. And then we grouped all these unchangeable file data into blocks. When all the blocks joins together, it forms a chain. So we call this technology a blockchain. So what is more important to guarantee the security of transaction on the blockchain is a fourth concept here. It's called a consensus mechanism. They are the rules by which the network participants agree to record data on the ledger and decide which transactions are legitimate. And all these transactions are coded into the protocol, so it cannot or easily be changed or updated. So put it simply, say if a hackers want to hack into a blockchain network containing thousands or millions of computers, if they hack into one of the files on the blockchain network without authorization, then all the other clean copies throughout the network will automatically override any amended record by the hacker. So this feature guarantees the immutability of this network, and also the trust among the stakeholder, because no one can change anything on the blockchain. And it's also economically not profitable for the hackers to attack a blockchain network, because they have to, if they want to change any details there, they have to hack into all the computers, maybe thousands or millions of computers on the network with their 1 second delay. That is technically quite difficult for the hackers to do so. On a blockchain, one of the mechanisms here is called proof of work, POW in short. It is competition among miners to get to mint the next block through a process called mining, and it is quite costly and uses a lot of computational power, while the miners who successfully mined a coin will get rewarded with a Bitcoin if it's a Bitcoin applications. However, as you may be aware, a lot of stakeholders have criticized blockchain of being a giant energy consumers because of the mining process, and where the different data centers have to consume lots of electricity in order to mine different cryptocurrencies on the blockchain. So that was what I call blockchain 1.0. Now on blockchain 2.0, we have a new mechanism called proof of stake, POS in short. It is an alternative to proof of work that I taught on the last slide, and it tries to overcome scalability concerns. It removed the guessing games and still has the incentive of good behavior on the blockchain network. And under POS, mining no longer requires specialized and powerful hardware. So it involves very low energy consumption, and it is more environmentally friendly way of using this technology. Of course, there are other mechanisms under development or testing, like pool burn, pool elapse time, pool authority, or pool activity, etc. Yeah, and on top of POW and polls here, so we have to stay tuned for all this fast-moving technology developments. What is even more important for to understand how blockchain applications work in dealing with in automating transaction is the concept of smart contracts. Smart contracts are agreements that are encoded in a computer program and automatically executed upon certain criteria being met. Advantages of smart contract include improved quality of transactions, reduced contract execution costs, and increased speed. A smart contract can be stored on a blockchain. So in layman terms, if you find it still difficult to understand what smart contract is, imagine that when you use Microsoft Excel spreadsheet, you have a formula function called if. I hope you remember it. Yeah. If A, then B. So on an Excel spreadsheet, you probably input in a formula route with if cell A1 equals 1, then cell A2 equals 2, along this logic. So smart contracts actually works according to this logic. If A happens, then B happens. The role of smart contract technically here is to automate the entire process by producing a B, making B happen after it's detected A has happened. Depending on how we design the smart contract and what kind of data will fit into its oracle to activate the entire automated process. Smart contract is also known as chain code, which are program rules and decision points into blockchain transaction and processes. A lot of applications, particularly those on climate change transaction are actually hinged on a smart contract running on the network. As I said, it automates a transaction and ensure that all parties are following the same rules. Even when it is a holiday, smart contract doesn't take a break, so it keep automating the transaction that we human being will have pre-programmed, depending on the design of our blockchain network and for what purpose we want to fit that network to. And we will and then a smart contract can be stored on the blockchain, and it addresses the even limitation of Bitcoin protocol. Smart contract provide autonomy and accuracy as it replaces human intermediaries with executable codes and ensures that the consistent execution of the process throughout. And it provides backup also, as a blockchain and a smart contract deploys to it provide a permanent record, allowing for auditing, insight, and traceability even if the creator is no longer in business. Smart contract also provide efficiency. The removal of intermediaries often results in significant process efficiency gains, and hence the cost savings, as the removal of intermediaries often provides significant transaction cost reductions. Okay, this is we come to the last concept, key concept blockchain is about token and tokenization. Probably a lot of you have heard of this term token before. A token represents a set of rules encoded in a smart contract. Each token belongs to a blockchain address. It is essentially a digital asset that is stored securely on the blockchain. Tokens are often most often known to be cryptocurrencies such as Bitcoin or Ether tokens. However, they can be anything from votes in an election to licenses to even ownership of a song. Some transaction platforms offer built-in token architectures to allow you to create your own token or coin. And these are the programs that run on the blockchain or programmable digital assets. Yeah, however, tokens are not necessarily coins. Tokens represent a service, a utility, or an asset. They can be traded like other cryptocurrencies. But coins can only be used as cryptocurrency or to store a monetary value. So they're not equivalent to each other. So you can buy a token with a coin, but not the other way around. Yeah. However, I would like to correct a major misconception on Bitcoin and blockchain. Bitcoin conceptually is not equal to blockchain. So Bitcoin is just the cryptocurrency that made blockchain platform famous, but it's not equivalent to blockchain. Analogically, so I would say blockchain looks like a iOS or Android operating system on your phone, and Bitcoin looks like an app. And then if you don't like Bitcoin, don't worry, you just uninstall that app and get a new one, but you won't throw away your phone. That doesn't make sense. So the main point, really important I would to convey to you, is that Bitcoin conceptually is not equal to blockchain. So there are different types of blockchain, public, private, with different write or read jurisdictions. We would let everybody or just specific participants read a public or private blockchain. Depending on the purpose we use. They're also open or closed blockchain. In an open blockchain, everyone can read blockchain data. In a closed blockchain, only specific participant can read data. Because we don't have time to go into deep details on which types of blockchains is used for what, I'm sure when the recordings or some materials are available on CTCN website, then you might want to read through these texts line by line. But I'm sure many of you are quite interested in how green assets or carbon assets can be tokenized to operationalize Paris agreements. Yeah. stay tuned. We will go through these concepts bit by bit over the next 5 webinars until the end of January. Now, if you have any question, feel free to type it on the WebEx, or if you think about some new question afterwards, feel free to email our Director General's office. We'll have colleagues dealing with your question. And now I pass the time to Dr. Adrian McCullough or John Krause to talk about the governance on blockchain.
Thank you, Alistair. Thanks for the presentation. I just second quickly what Alistair said. Please use the Q&A function to submit your questions already now, otherwise you might have forgotten them at the end. And in the meantime, I would hand over to Adrian now to provide his guest contribution on the topic of blockchain governance. Over to you, Adrian.
Thank you, Valentin. Hopefully you can all see my screen now. Good evening, good morning, hi to everyone. I am a lawyer. This is my disclaimer. I do it every time. Basically, this is a very fast-moving area. I'm not providing legal advice or professional services advice. It is a fast-moving area, and what I say now may not be correct tomorrow or the next day. So if you do have an issue, talk to someone that has the requisite expertise to assist you. Short outline, I'm going to skip over the first 3 slides because Alistair's done a very good job on explaining blockchain technology. I will jump into the governance. Blockchain has some very interesting governance difficulties, stakeholder involvement, importance, why we need governance in this area, smart contract and governance. There's a whole heap of characteristics. You can read these at your leisure. Hopefully you'll be given a copy of these slides and we can just skip over that. I also am part of the International Standards Organization, TC, Technical Committee 307 with Alistair. And there are 10 issues that the ISO group are looking at. And the big 3 that I see at the present moment are interoperability, governance, smart contract development. Outside, because it's international standards doesn't deal with legal issues per se, there are a lack of settled regulations dealing with blockchain and digital assets and smart contracts. And that's being looked at by various regulators. IOSCO, for instance, the International Organization of Security Commissioners, are very interested in this area. So let's look at, when we look at the Oxford English Dictionary, I apologize to anyone in, say, Europe. They probably don't look at the Oxford English Dictionary that much. We talk about governance as an action or fact of governing an activity, direction, rule, regulation. In economic terms, we define it as the use of institutions, structures of authority, and collaboration to allocate resources and coordinate the effort and activity in society or in an economy. In an IT perspective, we talk about IT of an organization, the organization strategy. The difficulty with the general definition of governance is that it's concentrating on a single entity. And as Alistair identified, you're going to have multiple copies across multiple jurisdictions of this database. So it's very difficult to use the standard definitions or traditional definitions of what we mean by governance. So blockchain technology involves a network of participants, as Alistair has identified. Now, it's not clear the elements of, it is clear the elements of the blockchain include a network of participants who may not have or know each other or even trust each other. That was the whole point of the Nakamoto paper, is being able to do non-face-to-face transactions whereby you don't even have to trust the other party. You have to trust the technology that they're utilizing in order to do the transaction, but you don't have to trust each other in relation to that transaction. So when you're doing a carbon credit transaction, you'll be able to do that without even knowing necessarily who the other party is. In general terms, you will, but you don't have to trust them. The technology will create this trusted environment for you without any human intervention or central authority. Now, Deventner, Brewster, and Everts have come up with this, that when we talk about blockchain governance, the means of achieving a direction, control, or coordination of stakeholders, like the nodes that run the various instances of the blockchain, within the context of a given blockchain project to which they jointly contribute. Professor Mark Staples, who's also on TC307, defines it as a decentralized aspect of blockchain causes its governance to differ from existing governance structures, such as markets and hierarchies. Because you have this multiple grouping of people, you can get what's called the tragedy of the anti-commons, which was developed by Professor Garrett Hardin, whereby if you have, think of the UN Security Council, for example. China, Russia, the United States can veto any transaction or idea that comes towards the security. That is a form of anti-commons. In other words, one party can stop the whole ball game, and that has actually happened with Bitcoin, with the SegWit creation, which was segregated witnessing, which was designed to improve performance. When we talk about stakeholders in Bitcoin, for instance, and Alistair's 100% correct. When we talk about Bitcoin, that is actually different to blockchain. When you read the Nakamoto paper, you'll identify that he never actually uses the term blockchain. He uses the term a chain of blocks. It was actually a computer scientist, Hal Finney, who first used the term blockchain. So you have these core developers. You have approximately 8,000 node or mining operators, digital currency exchange, and you have very large, what are called whale investors. These people are the real stakeholders in the development of blockchain development and Bitcoin, for instance. We have core developers who create what are called layer 1 code. Layer 2 code has been released, and there was a bit of a debacle on what's called a decentralized autonomous organization. DAOs were designed to be venture capital structures, and there was a failure in the coding. That's when I said you have to trust the code or the technology. Unfortunately, there was an error in the DAO code on the layer 2, and someone was able to siphon off about $50 million worth in value in Ether, and that caused a major problem for the Ethereum blockchain. You have these things called curators, is a person who will undertake a perusal or opportunity of the DAO. The DAO was really a structure for venture capitalism to allow everyone, it's like an egalitarian structure whereby people could vote on projects, but how do you determine which projects are worth voting on? Well, that's what the curator did. I'll skip over this slide. The governance of a blockchain project is crucial for its sustainability, as it enables stakeholders to discuss and make decisions on how the blockchain should evolve. And you have two types of structures here. You have this, how are we going to manage the blockchain, and how are we going to manage our project within the blockchain? So you have two, not competing, but you have to have understanding of both of these elements in order to have a successful project. So effective blockchain governance is also essential for successful implementation of blockchains and for the ability to adapt, change, and interact. Now, when we talk about the Bitcoin, there really is a decentralized, there's no one organization that's running it. If you talk about Ethereum and a lot of the other types of blockchains like Cardano or EOS, and there are many of them at the present moment, you usually do have a an overarching organization that will not run the blockchain, but will have a very strong influence. And the Ethereum Foundation with Vitalik Buterin is running, in essence, the structure of the Ethereum blockchain. You can go to the Cardano blockchain, which is a different kind of blockchain, and you have Charles Hoskinson's group with the Cardano Foundation. I now want to talk quickly, and I apologize that I'm going rather quickly through this, but there is a lot to talk. I also have given, not only can you have these slides, but I've done a recent paper on teaching lawyers how to draft traditional contracts so that they can later be converted into smart contracts, which people may be interested in, and that can be distributed as well. Smart contracts are in most cases neither smart nor are they a contract that would be recognized by law. And that means law in Europe and the codification, or in common law or civil law jurisdictions. Smart contracts are automated programs that transfer digital asset rights within the blockchain upon certain triggering conditions. I actually don't like the term smart contract. I think a better terminology would be transaction event response code. So you need a transaction, you need an event, and the smart code monitors those events in relation to that transaction, and it will create a response by storing something, some record in the blockchain. And that's really what we're talking about when we talk about smart contracts. And I prefer smart legal contracts, and I'll explain that in a second. So traditional contracts are non-deterministic in that they generally comprise language that is fuzzy in logic and subject to variance. I'll give you a clear example. If the lessee of a lease does not rectify the breach of the lease within a reasonable time, then the lessor is permitted to immediately terminate the lease. Sounds reasonable. But how does a computer understand reasonable time? This is an example of non-deterministic language, and computers operate in a deterministic environment unless you're using artificial intelligence, where you can use what's called fuzzy logic associated to that. Computers don't operate very well in non-deterministic environments. A better way of looking at it is that in a deterministic language, if the lessee does not rectify any breach of the lease within 10 days after the landlord has notified the lessee in writing of the breach, then the lessor is permitted to immediately terminate the lease. This is deterministic language, and the reason it's deterministic language is that a computer can calculate very easily 10 days. It doesn't have to worry about reasonable time. It goes, well, what the hell does reasonable time mean? Well, it can actually calculate 10 days very quickly and move forward. Now, what if a court determines that 10 days is not a reasonable time? And so the court then comes back and says, that's unenforceable. You've created an unreasonable amount of time. So Thompson and Sejas have said traditional contracts are fundamentally different from contracts that are meant to run on top of a blockchain. In the traditional model, enforcement of the contract is responsibility of the legal system. In the decentralized blockchain model, there is no central authority. The contract needs to be enforced by design. That is true. The smart legal contracts are meant to be enforced by design. Transaction, event, response. But code is not law. You cannot oust a court's jurisdiction, not in Europe, not in the United States, not in Australia, not in the United Kingdom. The court must have final determination as to what is or is not reasonable. So from a coding perspective, it's difficult to accommodate implied terms or terms incorporated by reference. But further research needs to be undertaken on this topic. Courts have uniformly noted that they prefer contracts to be complete in structure. They call them self-contained. In other words, you don't have to go out to some other documents, and they have strict interpretation. So a smart legal contract is a natural language contract that is fully or partially converted into a computer language that is able to be complied into some code that will operate on the blockchain. Also, once it's deployed, if it's on the Ethereum blockchain, it actually gets embedded inside a block. Remember what Alistair said. Once you write something to the block, it becomes immutable, which means you can't change it. So you have these conflicting aspects in relation to smart legal contracts. One way to overcome that, if you do need to change it, and we have variation clauses associated with contracts, you can have what's called a kill switch inside the program, and it may be that it can only be killed or stopped, the program can be stopped by a court order, or if the parties agree to it. So no single party can actually, so if Alistair and I had this smart legal contract, I can't override Alistair's will by activating the kill switch. I'd have to go to court, get the authority, and then I can do it without Alistair's assistance. So smart legal contracts can, in the right situation, reduce costs substantially from a contract administration. Think of a carbon credit trading exchange. Now, Singapore is developing what's hoping to be a global carbon credit exchange. Carbon emitters will need to offset their carbon emissions by acquiring time-restricted carbon certificates, which could be represented by a digital token stored in a carbon credit blockchain system that are managed by carbon credit smart legal contracts. Emitters would buy these tokens to cover their emissions for a 12-month period, and if they're still in operation, they still require, they can automatically renew these carbon credit tokens. This is a really interesting slide, and this is the last slide apart from my conclusion. This is developed by the CFTC. CFTC is the Commodities Future Trading Commission in the United States, and they manage markets. And they've looked at what are the benefits of smart contracts in a commodity market, like a carbon credit trading scheme, and what are the detriments that can arise. And I'll let you go through this slide on benefits and detriments. They're pretty self-explanatory, but it's a very good slide to actually try to analyze and understand what's happening. So a blockchain is a replicated data repository that has special security characteristics that can disintermediate unnecessary parties and yet still provide the trust requirements in a non-face-to-face transaction. Note that not all third parties or intermediaries will necessarily be disintermediated. Some regulators may say this organization must stay within the transaction, even though you could, through the technology, disintermediate them. It gives some basis to the regulator, have some confidence in the structure. Being a replicated data repository, changes to or enhancements to the underlying code that creates the transaction environment can be stifled due to the many influential stakeholders, and thus a tragedy of the anti-commons can be established if appropriate rules are not established. Smart contracts can, in certain situations, substantially reduce the contract cost and the management and administration of it, but the deployed code must be carefully tested prior to deployment. Otherwise, a similar result to the DAO could arise. And there are organizations and test beds that you can utilize, especially on the Ethereum blockchain, to test your software quite thoroughly. And that's it. Hello?
Hello, thank you everyone. Thank you to Alistair and to Adrian for your presentations. Please put your cameras on. We've now got just 10 minutes of question and answer for everybody that wishes to put questions to our two speakers today. I'm John Krause, I'm the Chief of Staff the BCI. So I was interested in particular, we've got one question so far that's come in. Please, if you're listening to this, do put further questions into the Q&A and I'll pick them up as I can. I was interested to hear what Adrian was talking about, mentioning the carbon credit trading exchange and Singapore's plans for doing that, because the question that we've got in the Q&A is, can we refer to any examples of the application of smart contracts in carbon markets or in climate technology that have been implemented so far?
My understanding is that there are no blockchain smart contract implementations dealing with carbon credits at the present moment. We need to really understand that blockchain at the present moment is still some nascent technology. We're still developing a whole heap of things. As I said in my discussion, there are many types of blockchains, many types at the present moment. We have the Cardano, for instance, is very different to Ethereum. Cardano uses a language called Haskell and Plutus, whereas Ethereum uses Solidity, which is a JavaScript-based structure for its language. There will be Singapore is really trying to capture the attention of many organizations across the world in the development. It's going to take probably another 18 months before they actually get their carbon credit trading exchange up with the blockchain. The benefit of it is that Alistair mentioned NFTs, non-fungible tokens. A non-fungible token is different from, say, a cryptocurrency. A cryptocurrency, one currency is exactly, say, one Bitcoin is exactly the same as every other Bitcoin. With an NFT, one NFT is unique. It can't be exchanged for another NFT of similar value or structure. So when you look at carbon credit certificates, every one of them will be unique. They'll have a unique number attached to them as part of their data structure, so that you need to buy multiple carbon credit certificates in order to, if you wanted to offset your carbon emissions, your that's what it's called, isn't it? Greenhouse gases, your GHG emissions. But you're right, there's none at the present moment.
Thanks, Adrian. And just to comment, someone's asking about sharing this presentation. Yes, we will be sharing it on the CTCN website in due course. A question maybe for Alistair from one of our listeners, Eric Butcher, and Adrian, you may want to chip in too. Eric's saying, well, what one reads of the threats of the blockchain technology, specifically the security of it, with the advent of quantum computing, is the advent of quantum computing a real threat to the security of blockchain?
Yes, thank you for the question on quantum computing. I think it's a very insightful question. So quantum computing is still not a, you can't buy a quantum computer in a high street yet. And it's still very much at the developmental stage, or even being used for national defense purpose, I guess. But of course, I think this is a valid point for a further study and discuss. So my personal view is that the use of quantum computing does not necessarily pose a threat to or break all those cryptocurrencies. I understand there's a lurking fear in cryptocurrency communities about quantum computing, but my simple answer is no. And then I think we will need to understand why this is why the cryptocurrencies cannot be broken by understanding in detail how quantum computing will interact with cryptocurrencies. But actually, in my plan is something that I would like to discuss further in the last webinar in January, after we talk about the value chain. But perhaps Adrian, have you got any immediate thoughts to share?
Yes, about 6 weeks ago, NIST, the National Institute of Science and Technology in the United States, published a paper basically saying that at the present moment, public key crypto systems really have no threat at the present moment from quantum computing. If you look at the quantum computing works on basically qubit sizes, and IBM has produced, I think it's a 180-bit qubit structure. And a company, as of 2 days ago from MIT, a startup out of MIT, has done 256 qubit, very big improvement. But the difficulty with public key crypto systems is that they use, most of them will use an elliptic curve or discrete logarithm over a finite field or integer factorization. Now, Peter Shaw in 1996 identified that every one of the public key crypto systems that are currently in place, those 3 in particular, are all susceptible to quantum computing. But the size of the qubit needed can be up to 10,000 qubits. We are well and truly short. We're looking at 250 qubits at the present moment. So that's why NIST has pointed out that at the present moment, blockchain and public key crypto systems are not under immediate threat. Irrespective of that, the NSA, National Security Agency in the United States, is investigating what are called lattice models, which are public key crypto systems originally developed by a UCLA professor, Robert, can't remember his last name, but they work off very large matrices, and they are what we call quantum crypto resistant. Hash algorithms are themselves quantum crypto resistant, unless you wanted to, if you had the large enough money to implement what's called Grover's algorithm. But even the NSA has said that they don't have that sort of money.
Thank you. Probably got time for one more question before we need to wrap up. Kathy Lee, who thanks both of you for being so insightful in your comments, also asks, do we see any concerns or challenges for blockchain in respect of civil society stakeholders? In other words, how can we ensure that blockchain is used in a way which is socially just and gender responsive, so equitable and fair development?
I'll be honest, I haven't even thought about that approach. It's a piece of technology. There are certain issues because the blockchain is distributed equally across all of the nodes. There are certain privacy issues that you wouldn't want to put literally on the blockchain. What you can do is, if you have a piece of personal information, what you can do is store that in a separate location, take a hash of that piece of information and store that on the blockchain. So therefore you can create environments where they can be personally, they can meet the GDPR, for instance, General Data Protection Regulations. The other thing that you need to be very much aware of is that, different from Cardano, the Ethereum blockchain, the actual smart contracts are, they run through what's called a Ethereum virtual machine, an EVM, that creates some bytecode. The bytecode is actually what gets stored on the blockchain, not the source code, but the bytecode. Now, the difficulty with that is that I could go through an Ethereum blockchain, extract all of the smart contracts, and I can reverse engineer them. So I can know what the transactions are, what they relate to. So there are some intricacies, and that's why Cardano has decided that you can do what are called off-chain transactions. In other words, the smart contract doesn't sit inside a block, it sits off the block, and therefore you can put your own structure in place so that you can't, I can't look at a Cardano smart contract and reverse engineer that to find out what's happening. So
okay, thanks.
We still have some outstanding issues in all of this.
Thanks, Ed. We're running right up against the clock. I don't know.
I do apologise.
Whether Alistair, you want to give a 15-second comment on that point before we hand over to Valentin to wrap up?
Yes, of course. The use of a blockchain can, as I said, tokenize a lot of things, or we call it fractionalize a lot of otherwise traditionally very huge investment size. So when it comes to a gender responsive use of blockchain, if in developing countries, women can benefit from the fractionalization of these investment capital, or in the interest of microfinancing for the development needs, then I think it will fundamentally change the rules of the games currently in place in many of the least developed countries.
Thank you, Alistair. Thank you, Ed. We need to wrap up there, so I'll hand over to Valentin just to close the session. Thank you.
Yes, thanks a lot to Adrian and Alistair for the presentation and the webinar today of Blockchain 101 and governance. It was a quite technical session today, but a very important session to prepare your understanding for the next few webinars when we dive into different topics related to climate change agendas. And next week, upcoming already, the first topical webinar on clean energy. It's next week, same day, same time, Friday from 1 to 2 p.m. CEST. I've just pasted the link to register for this webinar in the chat box here in this webinar, so please feel free to join. We will hear 3 experts next week, first of all, presenting transitioning to clean energy through blockchain, a kind of introduction by Dr. Hazel Reed, who is Director of Research at the BCI, and then have 2 use case presentations, a bit more hands-on, first of all, by a Power Ledger company on enabling orderly transition to renewables through blockchain, and then by Base on energy savings insurance and blockchain. So we're looking forward to next week's webinar and also to your participation there. Stay in touch, and we will upload all the documents and the recordings in the coming days also on the CTCN website. Thanks a lot for your participation, and have a great rest of the day and great weekend.
Everyone.
Bye.
Bye.